What's up, math brainiacs? Welcome back to Arithmophilia. Don't forget to subscribe. For today's video, we are going to talk about the factors of polynomials. Specifically, the techniques in factoring polynomials and how it can be done. But before that, let us be guided of our objectives that we need to achieve at the end of this video tutorial. First, describe the different techniques in factoring polynomials. Next, factor polynomials applying the different factoring techniques, and lastly, solve real-life problem involving factoring polynomials. Okay, without further ado, let's now start our discussion, starting with how to factor polynomials. When we factor polynomials, we express it as a product of two or more polynomials which are irreducible, that is, polynomials which cannot be factored into polynomials of lower degree. In doing this, there are several techniques to consider. First, the common monomial factor. This technique is based on the distributive property in the form of ax plus ay equals a times the quantity x plus y. Example: factor 4x cubed plus 8x squared. Here, we will identify the greatest common factor of both terms. We now have 4x squared times x plus 4x squared times 2. Looking into that expression, we say that 4x squared is their common factor. Therefore, we will bring that one out to have the final answer, 4x squared times the quantity x plus 2. The second technique we are going to discuss is the difference of squares. It states that the factors of a difference of two squares are the sum and difference of the expressions being squared, that is, in symbol, x squared minus y squared is equal to quantity x plus y times the quantity x minus y. For example, let us factor 16x squared minus 64z squared. Looking into the example, the coefficients 16 and 64 are both perfect square numbers, also their variables. We can rewrite this expression as quantity 4x squared minus the quantity of 8z squared. Applying the rule of difference of squares, we can have quantity 4x minus 8z times the quantity of 4x plus 8z. Understood? Next is perfect square trinomial. It is an expression obtained from the square of binomial equation which can be factored as the quantity of a plus minus b raised to 2, depending on the sign of the middle term. The patterns we need to be familiar with are a squared plus 2ab plus b squared equals quantity of a plus b squared. A squared minus 2ab plus b squared equals quantity of a minus b squared. For example, factor x squared plus 20x plus 100. Since the first and last term are perfect square, simply get their square roots. We have x and 10. Applying the factoring technique, we can rewrite the expression as quantity of x plus 10 squared, since all the operations are addition. Next example is factor x squared minus 20x plus 100. Again, the first and last term are perfect square, simply get their square roots. We have x and 10. In contrast with the first example, here, we have subtraction. Therefore, we will use the second pattern of this rule. This gives us quantity of x minus 10 squared. The next technique is what we called factoring quadratic trinomial. To factor quadratic trinomial in the form of x squared plus the quantity a plus b times x plus ab, we need to find two factors of the last term whose sum is equal to the coefficient of the middle term. To better understand this, let us consider this example. Factor x squared minus 2x minus 35. Again, we need to find two numbers whose product is negative 35 and whose sum is negative 2. Actually, this is a trial and error process. Looking into the table, the factors which satisfy the above condition are 5 and negative 7. Using these factors, we will write them inside the form being shown. Take note that it is not always addition. The operation depends on the sign of the factors. Therefore, the final answer is x plus 5 times the quantity of x minus 7. Next, let us discuss the sum and difference of cubes. The sum and difference of cubes can be factored into a product of a binomial and a trinomial. Below are the patterns we need to familiarize when factoring polynomials using this technique. Let us consider the following examples. Example number 1. Factor 8x cubed plus y cubed. We can rewrite this expression into quantity of 2x cubed plus y cubed. Please note that 8 is a perfect cube number. It is the result of 2 being multiplied by itself 3 times. Applying the first pattern of this factoring technique, we now have quantity of 2x plus y times the quantity of 4x squared minus 2xy plus y squared. Another example is to factor x cubed minus 8. This expression can be rewritten as x cubed minus 2 cubed, which will give us the factors quantity of x minus 2 times the quantity of x squared plus 2x plus 4, applying the second pattern of the technique. The last technique we will discuss is the factoring by grouping. If in some cases there is no GCF for all the terms in a polynomial, we can use this technique. For example, factor x raised to 4 minus 2x cubed plus 3x minus 6. First step is to group the given polynomials into binomials. Second step, let us factor out a GCF from each separate binomial. For the first group, x cubed is their GCF, which will leave x minus 2 inside the parenthesis. Now, on the second group, we bring out 3 as the GCF, leaving x minus 2 inside the parenthesis. In the last step, we will factor out the common binomials. Therefore, we now have quantity of x minus 2 times the quantity of x cubed plus 3. I do hope that you have familiarized all the factoring techniques that we have discussed. This time, for you to hone your newly learned skills, try to do this activity in your notebook. This activity is entitled, "Come on, Factor Me Out." Your task is, using the techniques in factoring polynomials, find the factors of the following polynomials and state the technique being used. Good luck, brainiacs! This time, let's reflect on this question. How can knowledge on factoring polynomials will help us analyze and solve real-life problems and make our decisions? Let's go and see. For the application, Jordan is 2 years older than his brother James. If the product of their ages is 1 less than 5 times the sum of their ages, how old are Jordan and James? Are you ready, brainiacs? Let us now start solving this problem. The first thing we need to do is to assign a variable for their ages. So, we will let x be the age of Jordan, and x minus 2 as James' age, since it is mentioned that he is 2 years younger than Jordan. Next, we will formulate equations out of the clues in the given problem. First, we have x times the quantity of x minus 2. This represents the product of Jordan's and James' ages. Second, we have 5 times the quantity of x plus x minus 2 minus 1, as a representation of the product of their ages is 1 less than 5 times the sum of their ages. Equating this to expression, we now have x times the quantity of x minus 2 equals 5 times the quantity of x plus x minus 2 minus 1. Next step is to simplify our working equation. We need to distribute the variable and number inside the parenthesis. We now have x squared minus 2x equals 5x plus 5x minus 10 minus 1. Next, combine like terms in the equation. This gives us x squared minus 2x equals 10x minus 11. We will then transpose 10x minus 11 to the other side of the equation and perform the indicated operations. This yields x squared minus 12x plus 11 equals 0. This time, we can apply a factoring technique for us to solve the values of x. In the final equation, we can utilize the factoring quadratic trinomial to solve our problem. If you can still recall, using that technique, we first need to identify two numbers whose product is 11 and whose sum is negative 12. Looking into factor table, we have identified negative 1 and negative 11 as our factors. This will give us the factored form of x minus 1 times the quantity of x minus 11. To get the values of x, we will equate these two to 0, which will give us the values of x, which are 1 and 11. So, since Jordan's age is x, Jordan is either 11 or 1 years old. However, since James is 2 years younger, Jordan can't be 1 because if he was, James would be negative 1, which is impossible. Therefore, Jordan's age is 11, while James is 9 years old. At last, we have already solved the problem. Before ending this lesson, please take note of this. For you to measure your previously learned understanding on factoring polynomials, you can answer the 10-item test that I have prepared for you on my quizzes.com account. How? Just search or click the link in the video description below. Enjoy! This ends our lesson for today. Thank you, Brainiacs. See you on our next episode.